In this video lesson, you will learn about event sourcing and how we're going to use it in our microservices that are powered by Axon Framework. Let's consider an example of how we persist information in a traditional application that does not use event sourcing, and then we'll have a look at event sourcing example. So let's assume we have a database that stores products that we sell in our e-commerce store. When a client application sends a HTTP request to create a new product, our application will store product details in a database. Now, when a client application sends a request to update product details, our application will find this product in the database and it will update an existing record with a new product details. So a request to update product details will not create a new product in our database. It will simply update an existing record with new product details. And when a client application sends a new request to update product details again, our application will again find a product in the database and will update an existing product with new product details. No new record is created and we simply update an existing record with new product details. No matter how many times we update our product details, in the database we will always keep one single record with the latest state of the product. Now let's see how event sourcing works. When we add event sourcing to our application, then instead of persisting only the final state of the product, we persist an event object that took place in our application. When client application sends a request to create a new product, our application will handle this request, it will process this request, but it will also store information about the request as an event that took place. For example, when our application handles a create product request, it will create and store an event object called product created event. The database that stores event object is called event store. Now, when client application sends an update product request, this will result in a product updated event created and stored in an event store database again. Notice that in the event store database, we do not update an existing record, but we store a new event that took place as a new record in a database. And when the client application sends a new request to update product details again, this will result in a new product updated event created and stored in the event store database. So when using event sourcing, we ensure that all changes that were made to product details are stored as a sequence of events. Now, because we have stored all events that took place, additionally to learning the final state of the product details, we can also learn how we have arrived to that state of the object. We now have a historical data that we can use for audit purposes, or we can use it to reconstruct the state of the object at any given time. Now let's see where event sourcing is used in CQRS application. So here's a diagram of a product microservice that we have split into two APIs to adopt to CQRS design pattern. On the left side we have a command API and on the right side we have a query API. When a client application sends a HTTP POST request to create a new product, the command handler will handle the command, a product create event will be created, and it will be persisted into a database which is now going to be called event store. The product created event will also be published for other components that are interested in this event to consume it. The event handler method in the query API, which is on the right side, will consume the product created event, and the read database will also be updated with a new record. Now, the difference between the event store on the left side and the read database on the right side is that the event store database will contain a record of every single event that took place for the product. But the read database on the right side will only contain one single record, which is the latest state of the product details entity. If we compare event store and the read database side by side, the event store will contain a sequence of events that took place for a product, but the read database will contain only the final state of the product. Another very important difference between the event store and the read database is that the event store will store the event details only. It will not store the entire product details object, whereas a record in the read database, it stores the entire product details information. Let's assume we have a web service endpoint that accepts HTTP requests to update product price only. When this event is processed, our command-side API will create a new event that is called something like product price updated event, and it will persist the product price updated event into event store. If you look at the event payload data that was persisted in the event store, it contains only product ID and product price. It does not contain any other information about the product. It contains just the data that was needed to update the product state. But the record in the read database will always contain the final state of the product and all the necessary information about that product that needs to be displayed in user interface. Because the event store contains all events that took place for the product, we have a historical data of it. And if needed, we can replay all the events in the event store and create a new or additional read database with different structure that can be used for a different view. Replaying of events can also be very helpful when debugging your application for a specific problem that happened in the past. Just replay events up to the point in time when an incident occurred, and they assess the current state. If you encounter a problem with application logic, you can fix it and then replay events again. Replay of the events does not always take place on our command. In fact, the replay of the events happens all the time when a state of the product is being loaded from the event store. Let's consider an example of the update product command. When our CQRS application that uses event sourcing handles the update product command, the state of the product will first be reconstructed by replaying every single event that took place for that product. And once the state of the product object is reconstructed, it will be updated with new details, and then a new event will be persisted in the event store. You might think that the event replaying feature is a performance issue, but apparently it's done very quickly, and even if there are too many events in the event store, then Axon Framework supports a feature that's called snapshots. You can make snapshots of the events in the event store and then replay events from a particular snapshot. Alright, so this was a brief overview of CQRS and event sourcing. Let's continue and let's learn more about it.